Hi guys. So in the class, we started to this worksheet, the fourth one. Okay, we solved some of the problems here. Today I will solve this 3L and M, right, and then continue the rest of the problems. So I will finish this worksheet in the video. If you have any question, we can start with your questions in the next class. Okay, then we can pass through the fifth worksheet. Okay, so I will write that question on the board here. So this part L, f of x, which is given by sinus of sine x squared. Right, so we will apply this chain rule if we're given a function in this form, f of g of x, then its derivative is given by this, f prime of g of x times g prime of x. Right, we will apply that. So what do we have here? We have first the sinus, so we start with that. F prime of x is equal to then cosinus of this function. Okay, times this inside function's derivative. So the derivative of this function. Okay, now what do we have? We have the same thing with the previous one. Okay, and the derivative of this function. So now we take the derivative of this function, which is cosinus of sinus x squared times this one's derivative now, derivative of sine x squared. Okay, now again we have the same time cosinus sine x squared and this one's derivative now. So we take this one's derivative, which is cosinus x squared, and the derivative of this function inside one, which is x squared, its derivative is 2x, right? But here in general, we don't write it at the end. We write it in here. So we have, this is the derivative of x squared, right? So this is the result, f prime. All right. We will solve also the part M, which is given by this, the root of x plus square root of x. Right, so let's rewrite this function as in this form, 1/3. Okay, first we need to apply power rule. So f prime is then 1/3 times x plus square root of x to the 1/3 minus 1, right? Times this one's derivative now. Okay, it's derivative prime. Okay, so what do we have? This will give this part will give minus 2/3. So we can rewrite it as in this form. This 3 comes from this part. So let's rewrite it as in this form. Okay. Times this one's derivative. So what's the derivative of this function? It's first one's derivative is 1 plus the second one's derivative is this. Okay. All right. Now we will solve this question 4. All right. Let's start with D. Again, we will find derivatives, and I will recall these the derivative of logarithmic function and e to the x So here you already have the worksheet, so no problem. So recall that the derivative of logarithmic function, inside we have f of x again, is given by this f prime of x over f of x. For example, if we have ln x cubed, we have its derivative is 3x squared over x cubed, which gives 3 over x. Okay, and another recall, if we have e to the g of x, then its derivative is given by this. Okay, another example, if we have e to the 3x, for example, then its derivative is this one's derivative, which is 3 times the same. All right, and another recall, this is the last one. So we have a to the g of x, where a is some constant, some real number, which is greater than 0. Okay, its derivative again given by this. The same with the previous one, but here we have ln of a. As ln of e is equal to 1, we don't rewrite it here, but here we have ln of a. Okay, now part D, we're given this function. We will find its derivative. Let's call this y, so we want to find y prime. Okay, now as we have this equality by the property of logarithmic function, we have 2 to the y equals to x, and taking derivatives of both sides with respect to x, derivative with respect to x gives us, we will apply this rule, this one. So here we have on the left y prime. As we take the derivative with respect to x, we don't have 1, we have y prime. Okay, we don't take the derivative with respect to y, but x. So we have y prime times 2 to the y times ln of 2. Okay, so instead of a, we have 2. And on the left, on the right, we have 1. Okay, now isolate this y prime, gives us 1 over 2 to the y ln of 2. And if we write this instead of y, if we write logarithmic function, this one, the given function at the beginning, what do we get here? Again, property of logarithmic function, we get there x ln of 2. As we wanted to find y prime, we're done. All right. Another part of this question. Let's solve I, which is this 4 over e to the minus x plus e to the x. So we rewrite it, as you can guess, as in this form, call it f of x. So we find f prime of x. We first apply the power rule. Okay, we get this times this function's derivative. All right, now what do we have? We have this e to the minus x plus e to the x squared times this one's derivative, which is minus e to the minus x plus e to the x. Just applying this rule here. Okay, so we're done. And another part, the last part of this question, J. So we're given this now. over cosinus 5x. So we rewrite this as in this form. Again, property of logarithm function gives us this cosinus 5x. Now we can take the derivatives. What do? We apply this. Okay, so the first one's derivative of this over the same function minus this one's derivative. So what's the derivative of cosinus 5x? It's minus sinus 5x times 5. This one's derivative is 5 over cosinus 5x. What do we get here? You know, you can write this x plus 2 to 1 over 3. So what do we get there? We have 1 over 3 times x plus 2 to the 1 over 3 minus 1, which will give this again, times this one's derivative is 1. So we don't write anything there. We have also this denominator plus sine 5 times sinus 5x over cosinus 5x. If you want, you can write this as tangent 5x. Okay, and we're done. All right. So we're done with this question 4. Now we have 5. So we will again find the derivatives of the given functions. Here we have part B. We're given x to the x. We rewrite it first. Okay, we rewrite it as in this form: e to the ln of x to the x. Okay, you know these gives 1, so we get x to the x. Okay, now what do we have? We can write this power. We can write this power as a multiple of this function. Okay, again by the property of logarithm function. Thus we get this. Now instead of dealing with, we will deal with this function. Okay, so what's the derivative of this function? We have e to the some function in terms of x. So this one's the power's derivative times the same function. So what's the derivative of this function? We have a product. So we will apply the product rule. First one's derivative is 1 times the second function. By first I mean this, and second I mean that. Okay, so we have ln of x plus first one times this one's derivative, which is 1 over x, times this function. So if we simplify them, we will get ln of x plus 1 times e to the x times ln of x. Right, so we're done. Now the part C. We're given this function ln of x to the cosinus x, right? So we do the same thing. We apply the same thing. We have e to the ln of x to the cosinus x, right? So as in the previous one, we have the same thing. We rewrite this cosinus, the power, as a multiple, cosinus x times ln of x. All right. Now what do we have? A minute. All right. So we have this one, e to the ln of this one, ln of x to the cosinus x. So if we're looking at this logarithmic function, we have this cosinus x as power, so we can write it as a multiple. We get so we exactly with the same with the previous one. So we have this one now. What's the derivative of this function? We have e to the some function in terms of x to apply the same rule. So this one's derivative times the same function. So we have a product. First one's derivative is minus sinus x times the second one. First one and the second one. Okay, plus first one times the second one's derivative. So what do we have? we have first this one's derivative over ln of x, right? Let's do that here. ln of x. Okay, this one's derivative is this part's derivative. Okay, ln of x's derivative over ln of x. So which gives this one's derivative is 1 over x. Thus we get this. Okay, exactly the same as that part, times e to the same function with the previous one, right? We can write it clearly as in this form, as you see. So we're done. Right? Okay, so we will solve this one, b, right? So we're given 1 over x plus 1 over y is equal to 1. Okay, here is the equals to 1. Okay, so first we will find the implicit differentiation. So it means we will take derivative directly without isolate that y, okay, as a function in terms of x. Okay, so we take both sides derivative. As you see here, you know how to take the derivative of 1 over x already. We have here. What about this? You can consider that as y to the minus 1. So we first apply the power rule. So it gives minus 1 over y squared. Okay, then the chain rule. So we need to take the derivative of y with respect to x. So we get y prime. As we see here, y as a function in terms of x, we write y prime. Okay, and on the left, on the right, we had 1, which is constant, so its derivative is 0. Now we need to isolate that y prime because we want to get that, okay, only. So just some basic operations, we get y prime is equal to minus y squared over x squared. Okay. Now here in the second part of the question, here we have okay. Now what do? We just isolate first y. Okay, first we isolate y and then take the derivative again of both sides. Okay, so we were given this function 1 over x plus 1 over y is equal to 1. Okay, so we isolate first y. So we isolate 1 over y first. We have this. Then it follows that y is equal to this quotient, right? Now we need to take the derivative of both sides with respect to x again. So on the left, we have y prime. And on the right, we just write this one as in this form, okay? So we need to apply power rule. We get minus 1 times this one's to the minus 2, right? Minus 1 minus 1 gives minus 2 times this function's derivative, which is 1 over x squared, okay? So here we have this and this gives minus 1 over x squared, and this one in the middle gives 1 over 1 minus 1 over x squared. Okay. Now what do we have? We had before this part. Okay. So it can be written as in this form. And we know already that y is equal to this. So instead of this, we write y. We get then minus 1 over x squared times y squared. So it means we have y prime is equal to minus y squared over x squared. Okay. So is it consistent? We had before y prime, sorry, here in the first part, we had before y prime as in this form, we found that, and the same in the second part. So they are consistent. Okay. They are consistent. Now 7. So we will find the implicit differentiation only. Okay, dy over dx. All right, part B, we're given this equality first. So we just take derivatives of both sides with respect to x. Okay, now on the left, first we distributed, as in this form, as you see, we distribute this x to the 4 into the parentheses and get that. And on the right, we have the same, we apply the same thing. So we get this. Now taking derivatives gives us that. So this one's derivative is 5x to the 4, and this one's derivative. So here we see this as a product of these two functions, the function x to the 4 and the function y. Okay, so first one's derivative is 4x cubed times the second one plus first one times the second one's derivative, which is y prime. Okay, do the same thing here. We have first this function and then this function. So we have 3y squared. The first one's derivative is 3. So we have 3y squared plus 3x times this one's derivative, which is this one's derivative is 2y times y prime. Okay, so we have this term here, and this one's derivative is clearly this. Okay. Now what do we have? We need to isolate y prime. So as you see, the computations, these are trivial or basic things. So we have y prime as this quotient. Okay. We say it's implicit because it doesn't only contain the constants and x, but also it contains the function y, right? That's why it's called implicit. Now, what about this? We have 4 cosinus x times sinus y equals to 1. Take both sides derivative. So first one gives that, again, we see this part as the first function and this as the second one. This one's derivative is minus 4 sinus x times the second one plus 4 cosinus x times this one's derivative, which is cosinus y times this function's derivative, which is y prime. Okay, and on the right we have 0. Now the only thing we need to do is isolating this y prime, which gives this. Okay, just divide this one in both sides, divide that part. So we get this, and you know sinus over cosinus gives tangent, so we can rewrite it in this form. All right. Here we're given again tangent x over y, which is equal to x plus y. So the derivative of tangent is second squared. We did before in the classes. How can we get that? We know it already. Okay, so we get second squared x over y times this function's derivative, right? Which is this. And on the right, we have the derivative of this function, which is 1, and the derivative of y, which is y prime. Okay, so we have this part again here. Okay, and this one, the derivative of x over y. So we have a quotient there, right? The first function is x and the second function is y. So we apply that rule. First one's derivative is the first one's derivative is, let's write it here, 1 times the second one minus x times the second one's derivative over y squared. You get the same thing here. Okay. And on the right, we have the same thing. Okay. So we just isolate that y prime in this equality. Okay, and get this one with the last quotient. It's pretty clear, so we just distribute it and isolate y prime. All right. Now what about this? We take again the derivatives. So if you write this one as in this form, so its derivative will be 1 over 2 times x times y to the minus 1 over 2, which gives this one. times this function's derivative, the derivative of x times y. And on the right, we have this one's derivative is 0, and this one's derivative. The first function is this, and the second one is this. Product rule. First one's derivative is 2x times the second one plus first one times this one's derivative, which is y prime. Okay. Now what do we have? This one's derivative is, the first one's derivative is 1, so we have 1 times y plus the first one times the second one's derivative. Okay, that's why we have this one here, over 2 times square root of xy, and on the right we have the same. And then we just isolate y prime to get the implicit differentiation. Okay, and we're done. Okay, now we will use implicit differentiation again, okay, for the given equalities. Okay, and then we will find tangent line at the given point. So here we have the first part. Now first find y prime. Okay, so first on the left we take derivative with respect to x. We have 2x plus 2y y prime. Okay, and on the right we apply first power rule, which gives this part, times this function's derivative. This is the derivative of the function inside of the parentheses. So the derivative of 2x squared is 4x. This one is 4y times y prime. And this one is minus 1. Okay. And then just distribute them and isolate y prime. We will get this. Okay. Now we know this point is on the tangent line, right? So we just plug this point first to find the slope. What do we have? Here it says that x equals to 0 and y is equal to 1 over 2. Okay, so we just plug them here, x equals to 0, okay, and y equals to 1 over 2. So we just plug them here into y prime, okay. You may consider this as f prime, f prime of x, okay. So we have then this one, which gives us, remember, the slope of the tangent line, okay. So in general, an equation of a line is this. Now we find the slope, which is 1. So we have y equals to x plus c. Now we need to find that constant, but we already know this point is on the tangent line. We just plug x equals to 0 and y equals to 1 over 2 again to get that constant c, which is 1 over 2. Just plug in them, gives us c equals to 1 over 2. So we're done. This is the tangent line equation at that point. We will do the same things here. Just first find the implicit differentiation. So take both sides derivative with respect to x. So here on the left, we have this one. I don't tell that again and again. You get the point, I guess. So on the right, we have this. Okay. Now what do we have? We have this y prime. Okay. So at that point, we need to find first the slope of the tangent line. So we just plug x equals to 3 and y equals to 1. And you see we have 9 over 13, which is the slope of the tangent line. So this is the general form of the tangent line equation, right? Or in any line equation. We already know the slope, so we just plug that. Now to find c, again, put this point into this equation. Okay, we just plug x equals to 3 and y equals to 1 again. And c is then this one, this number, minus 14 over 13. So what do we have? We have this line equation, which is the tangent line equation at this point, 3, 1. Okay. And that was the last question. If you have any other question, if you don't get something here, we can start with this worksheet next week. Then pass to the next worksheet, 5th worksheet. Okay. All right. See you.